Hello, everyone. Welcome to Cloud Native Live, where we dive deep into the code behind Cloud Native. I'm Annie Talvasto, and I'm a CNCF ambassador as well as a senior product marketing manager at Camunda, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer all of your questions. So, you can join us every Wednesday to watch live. And we hope to see you at KubeCon next week. So you can still register. So grab those tickets and get into the cloud native space next week as well. Perfect. And this week we have Han Lin here with us to talk about how to build a multi-cloud database as a service. Very exciting topic for today for Cloud Native Live. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants as well as presenters. But that being said, I'll hand it over to Han Lin to kick off today's presentation.
All right, thanks. Hi, hello, hello everyone. My name is Han Lin, and it's a pleasure to be here today for the CNCF webinar. Oh, can you hear me? Okay.
Yes, we can hear you very well.
Okay, sure. My team is working on building a managed multi-cloud database, TiDB as a service product, and the TiDB operator is one of the fundamental building blocks for making that happen. In today's presentation, I'm going to present a live demo on how to create and manage a TiDB cluster using the TiDB operator on a Kubernetes cluster. Okay, let me change the slide. Okay. Well, before jumping to the details of Kubernetes operator and other cloud-native technologies, please allow me to do a brief introduction to TiDB itself. So TiDB is a MySQL-compatible SQL database. By MySQL compliant, it means you can connect to a TiDB cluster in the same way you connect to a MySQL instance. Different from traditional OLTP database that runs on a single instance, TiDB is a distributed system. Traditionally, when a database got excessive data, we need to shard the database, and it could be challenging to manage those shards. Using TiDB, on the other hand, you don't need to worry about the sharding, and TiDB will manage that for you. TiDB is inspired by Google Spanner, and it is also built on top of a KV store. In this case, the KV store is something called TiKV. TiKV is a distributed KV store empowered by RocksDB. For a KV store, the key range could be very huge, and we will reach the scale limit if we put all the keys into a single machine. To address that scale issue, we split the entire key space into multiple continuous key ranges, and we call them key regions. The concept is similar to shards. Key regions are distributed to different TiKV instances, and this is a superficial description of how we built a distributed KV store.
Perfect. And there's actually an audience question that popped in. So ITsploit asks, what is the difference between this and Vitess, which is also MySQL and CNCF?
Which database? Sorry.
Vitess, I'm not sure if I'm pronouncing it correctly, if you can see the comment there.
Oh, I'm seeing the comments. Okay. What is from Vitess? Okay, so Vitess is a shard management system. So basically, it helps people to manage different shards. But at the back, I think at the back end, it's still using the MySQL. But TiDB, different from Vitess, it doesn't have any shards concepts in there. So basically, for Vitess, because it's still using the sharding technology, so there's some limitations that probably you cannot do some join operation or something, but this is not the case for TiDB. So TiDB, since there's no such thing called a shard, so you can do all the operations that you can do towards a MySQL instance. So I think that's the difference. Okay. Okay. So I think the question is answered. So let me just
Yeah, perfect.
okay.
Thank you so much.
Yep, no worries. So when TiDB receives a SQL statement, so it will try to parse the SQL, generate a query plan. Okay, great. Generate a query plan, and it will determine in which key regions the required data is located. So now the question is, which TiKV instance hosts those key regions? Host those key regions. This is where PD comes into the play. So PD stands for placement driver, and one of its core functionality is it maintains the key regions to TiKV instance mapping. PD serves as the control plane for TiKV, and it also checks whether a certain key region becomes too dense or too sparse, and it will try to split and merge the regions dynamically. Finally, in this diagram, there's some component called TiFlash. So what is TiFlash? TiFlash is basically a column storage engine optimized for analytical processing. With the presence of TiFlash, TiDB is capable of handling analytical workloads without interfering with ongoing transactional workloads. Okay, so I will change the slide. Okay, now, I think we have some basic knowledge for TiDB. Then what is TiDB operator and why it's useful for us? Well, as we are seeing previously, TiDB has many different components, and managing it could be tedious and error-prone. TiDB operator is a tool for managing TiDB in a Kubernetes cluster. Similar to other operators in the Kubernetes ecosystem. Hi, Maha. Yeah. Similar to other operators in the Kubernetes ecosystem, we provide a set of CRDs, and the user can simply describe the desired state for a TiDB cluster, and the operator will automatically drive the cluster to its desired state. TiDB operator can do lifecycle management for TiDB cluster, set up the monitoring, and set up data change capture, set up things like data change capture clusters, and so on. Okay, let me change the slide. Okay, so here's the plan for today's live demo. First, we will cover the installation for TiDB operator. Then we will label the nodes in a pre-created Kubernetes cluster so that each component could be scheduled to a dedicated node. We will create a Kubernetes cluster by applying a TiDB cluster customized resource. So after the cluster is up and running, we will run the TPCC benchmark against that cluster, and we will log into the TiDB to check out the newly added database. Next, we will access Grafana and the TiDB dashboard to see the metrics being collected. We will also try to scale out and scale in the cluster and check out changes on the dashboards. Finally, we will clean up the resource we've just created. Notice this is a live demo, so things could go wrong. Any questions before the demo?
Not so far from the audience. Oh, now they're seeing me. Oh, someone asked if possible to get the deck afterwards. For example, are you gonna you may be thinking about putting it to GitHub or somewhere else? Is there a place where people could find it afterwards?
Okay, sure. I think I do have a Slack link. Let me find. Sorry, I do have a link for the demo. I'll probably handle it in the put it in the private chat. Chat.
Perfect. We can get
So
it there, and I think we can also include it to the materials that people get after the event and so forth. But
yeah,
also, if you are watching this live and your internet is poor and whatnot, you can always watch this session afterwards on demand on the CNCF YouTube channel. It's going to be added there immediately. So you can either look at the slides afterwards, or you can just watch the session play by play exactly as it happens. So no worries there as well.
Yeah, sure.
And then there was another question from Laurentinas. Could you share use cases that we are trying to accomplish using DPD that cannot be accomplished with other DB?
Okay. So accomplished using TiDB cannot be using other DB. Well, I think that really depends. I think there are different DBs on the market. Something are using a similar technology. I think Cockroach DB and others. These are similar to TiDB, but I think the major difference is from traditional OLTP database, for example, MySQL or Postgres. Those databases are, I think by default, they are something like pretty much single instance databases. So so you need to manage the sharding and other stuff, and that could be tedious, and that could also be very challenging in some cases. So for TiDB, I think the benefits for it is very scalable. It's very scalable. So and you don't need to worry about managing the shards on your own. So I think that's one of the major benefits. I think some other features could be it is marketed as a OLTP, HTAP database, so it can handle hybrid workloads like transactional and analytical, because I think after some time of development, people added some analytical processing data store, something called TiFlash. I just mentioned in the slide. So that means, for example, when you are handling both transactional and analytical workloads, those two kind of workloads won't really interfere with each other. So you won't see a very obvious performance drop if you are doing analytical processing, and on the same time you are doing transactional actions. Yeah, something like that.
Perfect. Sounds good.
Yeah.
Then there was another question on kind of continuing, I guess, a bit on that topic as well. So IT Split asks, I'm curious about scaling and disaster recovery capabilities.
Oh, okay. I think most of the disaster recovery capability is actually brought by Kubernetes. So Kubernetes has some components like stateful sets and deployments. So we use that for data. I think HA. Yeah. For example, if some pod is we are typically seeing that in our production environment. Sometimes TiDB pod got OOM'd. So basically, when we are handling some big queries, so we'll take a lot of memory to do the compute. And sometimes we didn't assign enough memory and the pod just crashed. And with the help of Kubernetes, the pod will be bring up automatically. So that's I think that's what the cloud native brings to us. Yeah.
Perfect. Then there was a from Jorge asks, TBD uses PBS to store data, right? Or is it like a middleman between apps and DBs?
Oh, I think the answer depends. So for some of the so TiDB as a cloud, I think in our use case we use it as a cloud native database and we deploy it in Kubernetes. When we deploy in Kubernetes, yes, it is using PVs as the data store. And for some use cases, people just deploy TiDB on a bare metal machine. So in that case, people will well, they're not using Kubernetes in that case. So people use local disk or something similar. Yeah. And
Great. And
okay.
then we had regarding the cluster config, how many nodes we can have, asks user.
Okay. Okay. So the number of nodes, I think there are several limitations in our use case. So we are deploying that on TiDB cluster on Kubernetes. And so Kubernetes typically, I forgot the exact number, but Kubernetes does have a node limitation. So that's one thing. And what our typical deployment is, we will assign, for example, there are several different components, TiDB, PD, and others. So all of them can have multiple replicas, and we basically assign a single pod to a single machine. So a pod and a machine typically have a one-to-one mapping in our practice. So I think one of the limitation could be the TiDB. Sorry. One of the limitation could be bounded by the number of nodes that can join a Kubernetes cluster. So that's one of the limitation. But apart from that, I don't really. I think there probably is also another limitation on how many nodes can join a TiDB cluster, but I need to check out the exact number. Yeah.
Yeah, no worries. Then we have ITsploit asking, how does it handle cluster/node upgrades where nodes will need to be refreshed with new nodes/node groups?
Okay, so handle cluster upgrade when nodes need to be refreshed with new nodes. Okay, so I think for upgrade is actually a little bit tricky. I think in our practice there are some rolling upgrades. I think what we will do is we will change the version number in the TiDB cluster CR object. But yeah, I think that could be a little bit tricky, but basically it will trigger some rolling upgrades. Yeah.
Perfect. And so far, the last on this cohort of questions, maybe Santosh asks, is TiDB NoSQL?
No, it's a relational database, just like MySQL. MySQL is a relational database, right? So this is also a relational one. Yeah.
Perfect. And we're going to have obviously more Q&A at the end as well as throughout the whole demo. So people keep on asking questions. Thank you so much for so many already. But I think we can hop on to the demo now.
Yeah, no worries. Okay. So I'm gonna try to switch to the demo screen. Okay. Okay. Is the font size okay? Do I need to increase the font size?
It looks good to me.
Okay.
But we can obviously see if anyone says anything. And actually, we had a new question here that we can answer while everyone can see if the font size is good. So, is it auto scale pods in horizontal or vertical? How does this support multi-cloud?
I see. So the I think it can scale both horizontal or vertical. So typically we will install something called a VPA. That means that stands for vertical pod autoscaler. So basically we will sometimes we want to increase the memory or CPU for example TiDB pods automatically. Yeah. So that's one thing. But also it can scale out. It can also scale out. So to scale out, I think we just need to change the replica numbers on the TiDB cluster spec to make it happen. Yeah.
Perfect. And then we can grab the kind of extra question from Santos as well. So, is there any cloud native databases which are NoSQL from open source?
I think there are a bunch of them. I think there are a bunch of them, but probably it's not really related to today's demo. Yeah.
Great.
Oh.
Do we want to grab the last question there?
Yeah,
So
sure.
many questions, which is amazing, but we also need to get the demo at some point.
Yeah.
Yeah. Do you want to hop on straight to the demo, or do you want to take this last question from Subhash?
Maybe the demo will take some time to load the data. Maybe I will kick off the demo and answer the questions during the wait. Okay.
Perfect. Sounds good.
Okay. Cool. So I think we've covered the plan for today. So let me switch to this terminal. Okay. So I've already created a Kubernetes cluster. Get nodes. So I've already created a Kubernetes cluster on GKE that has 7 worker nodes before this presentation. To simplify the demo, the cluster nodes are all located on US Central 1A. So that's the availability zone. In a typical production environment, in a typical production scenario, we would like to spread the workloads across multiple AZs. But for the sake of the demo purpose, we will use a single zone cluster. And the first thing we want to do is to install the TiDB operator. We are going to install it using Helm chart. and it's a popular application delivery tool in the cloud native realm. And let's add PingCAP's chart repository to my system. So here are the commands to add it to my system. Okay, it's already added. And then let's refresh it to make the charts up to date. Okay, sounds perfect. And the next thing we want to do is to apply the CRDs. Yeah, just like other operators, we need to install the CRDs first. Let me grab the CRD here. Okay, so we can install the CRD for version 1.3.9 here. Yeah, to confirm the CRDs are installed correctly, we can do the following command. Resources, and let's grab for PingCAP. So this will list all the CRDs installed in the PingCAP resource group, API group. Okay, it seems those are installed correctly. And then we want to create a namespace named TiDB admin, and we will install the TiDB operator under that namespace. So let me try to create a separate screen. First, create the namespace, and then let's watch that namespace and see what's going on under that namespace. -n TiDB admin get pod, and let's wait. Okay. Then on the upper screen, we will try to use Helm to install the TiDB operator under the TiDB admin namespace. And notice that we are using 1.3.9, which is the latest release for TiDB operator. Yeah. Okay. Now we are seeing that the pods are being created. So at this point, probably it's pulling some images. Okay, the status becomes running. Okay, that means the operator is supposed to be installed correctly. Okay. Let me just cancel that. The next thing we want to do is, in this cluster, we have 7 nodes, and we want to assign 1 node for PV and 2 nodes for TiDB and 4 nodes for TiKV nodes. So to tell the scheduler how to do the assignments, we need to label the nodes. So let's first label the first node for PD. Okay, the node is now labeled, and we will label the following 2 nodes for TiDB. Okay, nodes are labeled, and the remaining nodes, we will label them for TiKV. Okay, so I think the nodes are labeled correctly, but just to confirm, we can do a get node, and we provide a label dedicated equals PD, and we are seeing that 1 node is being listed, and for TiDB, 2 nodes are being listed, and TiKV, and 4 nodes are being listed. Okay, that means we are labeling correctly. And the next thing we want to do is we want to create a namespace that's for the TiDB cluster. So the TiDB cluster resources will be located in that namespace. We call that namespace demo. Now the namespace is created, and for the sake of the demo, we will switch the default context to demo. So in the remaining of the code lab, we won't need to type -n demo again and again. Okay. And okay, the next thing we want to do is we would like to download the sample sample Kubernetes cluster YAML, and we would like to do some changes to that YAML. The first thing we want to change is the replica number for PD. By default, it's 3, and for this demo, we want to make it 1. And we don't need that much storage size. For example, 10 gigabytes for PD is too much for this demo. We make it 5. And for the number of for the storage size for TiKV, we don't need the 100. We will just make it smaller, make it 10 gigabytes is enough. And the final thing we want to change is actually for TiDB. So to make the sorry, let me locate the TiDB service first. Okay, here we go. So to access TiDB to access the MySQL client, we would like to expose the TiDB service as a load via the load balancer. So here it originally by default it's using the internal one, but we want to access it in this demo, so we make it external. I think that's all the changes we need to make for this TiDB cluster object. Let's create it. Create -f TiDB cluster YAML, and on the second half, kubectl -get pods -w, and we should be seeing the pods are being created. It will only take a few minutes for those pods to come up. I think at this point the pod is the node is pulling some image, and after the PD instance is ready, it will try to spin up some TiKV pods. Okay, so TiKV is now up and running. Well, okay. Now TiKV nodes are being assigned, and okay, now TiKV are up and running. Yes, okay. And I think after TiKVs are up and running, then it will try to start the TiDB pods. I think we have 2 replica of TiDB pods. Yeah, we are seeing the TiDB pods are being initiated here, and the pod as the okay, now they are running in the running state. Cool. I think it will take a while for them to be ready. Let's try to get the TiDB cluster basic objects. Let's try to see a status. Okay, the status is now ready. So that means the cluster is now up and running. The next thing we want to do is we can connect to that TiDB cluster. What we will do is we can see what's inside what's in the database. So I'm just grabbing the endpoint for that TiDB cluster from the service, and then I'm going to connect to that TiDB using the MySQL client. Okay, so now it's connected to the TiDB cluster, and we can see the version number for TiDB cluster is 5.4.1. And let's show the databases. Okay, you can see initially it will have some default databases. Okay, so the next thing I want to do is I would like to create the monitoring components for it. So here is the, I think this is the monitoring tools. Let me first apply it, and I will explain what's inside. Yeah, On the bottom half, you can see the monitoring pod is being created. And what's in that component? I think this is only a default configuration for the monitoring. GitHub, and let's try to, yep, wait. Monitoring tool, PingCAP. Okay, so maybe just show the YAML, raw YAML. So basically this, you can see from the spec, basically TiDB monitor is a wrap on top of the Prometheus and the Grafana. And basically, apart from these two components, basically there's an initializer. The initializer has some built-in logic to load the configurations to Grafana and Prometheus. I think that's as simple as that. So this is a simple configuration, but for production, you probably need more fine-grained configurations, like the configurations for passwords or the durations. You want to persist the metrics for Prometheus, and these are all configurable in a fine-grained configuration. Okay, so now the pods are up and running. Let's try to run the TPCC benchmark against that cluster. So I will try to create that. I will try to create that. Let me create a new screen for that. Let's first grab the endpoint IP, and then run this command to load the data. Okay, as we are seeing some outputs, I think it is loading the data. And we can switch back to the MySQL client. And at this point, when we show the database, you can see there's a new base for TPCC being created here. And use TPCC. I think there are some tables newly created in that database. Show tables and select from, let's see, the items. Let's see the 5 items. Okay, you can see that there are some fresh stuff being added to that database. So it will take a while for the data to be loaded. So what the next thing we want to do is we want to see the we want to check out the Grafana dashboard and also the TiDB dashboard. So okay, it's still loading data, and check out the services in the system, and we can see that only in the default namespace, only the TiDB service, that's the MySQL endpoint, is exposed using load balancer. But for other system, for other services, these are all cluster IPs. That means these services are not accessible from outside of the cluster. So to expose to connect those services, we need to do a path forwarding. To do a path forward, yeah. So by running this command, we are basically porting the basic Grafana, the Grafana service to our local 3000 port. And similarly, by running this command, we are path forwarding the TiDB dashboard to our local port. All right, these are all being path forwarded. And we can connect to these services. For example, let's first try out the Grafana dashboard. Okay, so now we are seeing the Grafana, and by default configuration, it's using the default password, which is and it's a weak password to be honest. And we skip the change password command. And in this dashboard, see that there are some default built-in metric for TiDB cluster, and we can check out the TiDB details. And sorry, change this one. Oh, wait, wrong typing. And details, and we can expand the cluster, and you can see that the cluster has just been created. And let me change the duration to 15 minutes and refresh it every 5 seconds. You can see that cluster has just been created, and shortly after it is created, we are seeing some loads because we are running TPCC against it. And from this point, you can see that this is the metrics for regions on TiKV. So you can see that every instance got 39 regions. I think that is because by default we will replicate data. We will have the data will be replicated to 3 TiKV instances. Yeah. So every instance will have all the regions here. Yeah, and we can see that each regions, although we have 39 regions in total, and we are each TiKV instance is only like around 1/3 of the leader of 1/3 of the regions, something like that. Okay, then let's check out the TiDB dashboard. Okay, so this is TiDB dashboard. And we are seeing, okay, there are some queries, queries in the default dashboard, and we can check out the SQL statements. So TiDB dashboard is mostly used for troubleshooting, and we can, for each thing, there's a dashboard for SQL statements, so we can see the details, some statics for each single SQL statement. And we can also check the slow queries. So slow queries will do some statics for the queries that takes extra finish. And we are seeing these are typically have like around 300 milliseconds to finish. And by clicking on the queries, we can actually see, oh, okay, this is not very typical. Let's try to see updates, something like this. Yeah, for example, if we check out some of the SQL statements, and we can see that there's a detailed query plan for that SQL statement. And these information are very useful for performance tuning. Yeah. Okay, so this is a very basic tour for the Grafana and the TiDB dashboard. Let's go back to the screen, and the data is still being loaded. Okay, it takes some time to load the data. And as we are loading the data, that's the reason why we are not seeing some search like select or get all in this in the SQL statement section. So basically, all the SQL statements are something like insert and write to the database because we are currently loading data. Okay, well, it takes quite some time to load the data. And at this point, okay, so originally I think we have 39 regions. Now we have one more region because we are continuously writing the data. And what we can do at this point is we can scale out the cluster by changing the number of replica TiKV. So let's try to scale out the cluster here. So let's first check the current number of replicas in the system. So originally we in the TiKV spec, in the TiDB cluster spec, we are specifying 3 instances. We are just confirming that we have 3 instances for TiKV, and then we can do a patch here. We can create a patch to patch the number to 4, and you are seeing that instantly. We can see a new TiKV pod being created here. Yes, and we check the replica number here. It changes from 3 to, and now the new TiKV node is being initiated here. So for scaling out, typically we will the change will happen instantly after the change is applied, and it will take some time for the TiKV pod to up and running, and there will be some latency in the dashboard, and later on we are supposed to see a new TiKV in the dashboard. Let's go back to the okay. It's taking quite some time to load the data. Okay.
No worries. If there's some time, we do have a few audience questions that we can get to. Does that sound good? Or okay. So there was a question from Subhash. Can we use this TiDB in Java older versions like GTK 8? Will it be compatible or supported?
I think I'm not expert on that, but my understanding is I think TiDB has spent quite some time working on the compatibility issue with MySQL. So if your JDK can be connected to MySQL, I think it can be connected to TiDB in the same way. Yeah.
Great. And then ITsploit had a comment, and I think that they asked before about the cluster node upgrades and so forth, and then they continued. Tricky is the word when it comes to DBs and Kubernetes. A clear plan/process would be nice, especially with node refreshes/upgrades.
Yeah. Yeah. Okay. So I think for the upgrade issue, I think that does need some expertise. Sorry, I don't really have the expertise on that. So probably I will I can probably get back to my team and find more resources on that. Yeah.
Perfect. And then we had a person asking, is there performance benchmark available in comparison to MySQL, MariaDB, and Vitis, and so forth?
Actually, I'm not sure on that, and I think for the benchmark, it could be I won't say tricky, but it won't be. It would be a little bit unfair because MySQL is a single instance database, so it doesn't need to worry about the latencies between different components. But TiDB is distributed. It's very scalable. It can handle maybe bytes, not petabytes, maybe terabytes of data, but MySQL will be hard to handle that data, but data never leave the instance, so the performance could be better. So it's really how like what's the difference between performance versus scalability. So yeah.
No worries.
So
And
I think
then
there are
there was
some,
also
yeah. Sorry, by the way, I think there are some back for TiDB itself in the I think official website for PingCAP, but I'm not sure if they have performed the benchmark for different clusters page. Yeah, sorry.
yeah, perfect. And then there was I think 2 people asking about the Git link so that they can follow along with the steps that you're doing.
Okay, great.
Okay. And I think someone maybe linked it already.
Okay.
Or like they linked your docs link, but if you have the Git link, can obviously send it to the attendees via the chat as well. And then there was a question around Santosh asks, we should be having a TiDB driver connect from Java, right? But then I think Li Shen answered, since TiDB is compatible with MySQL protocol and syntax, you can use MySQL drivers to connect to TiDB. If you want to elaborate on that, obviously free to do so, but I think that probably at least was a good answer to kick off with.
Yeah.
Yep.
Yeah. Thanks. Thanks, Shelly. Yeah. Oh,
Yeah,
okay.
and then people are asking for the Git link, and then a question: is it free to use for production environments without any licensing complications? Question mark.
Yeah. Yeah. Sure. Yeah. Sure. TiDB is open source. I think under Apache 2 license. Yeah. Correct me if
Yeah,
I'm. Yeah.
yeah, and then a question was: as per architecture diagram, it uses RocksDB behind the scene.
Yeah. RocksDB as the yeah, like Shelly mentioned, RocksDB as the storage engine, and it's actually a library we use. Yeah.
Great, and I think that was it for the questions so far.
Okay.
Yeah.
Okay, sure. So let's get back to the panel, and we can see that after some latency, we can see the new TiKV3 nodes come up and running. And also we've loaded all the data finally, and we can run some analytical, we can run the some other, uh, instead of loading the data, we can actually run the test against the cluster. Okay. It's supposed to run some queries, and from the dashboard, let's try to refresh it. Okay, now we are seeing some, as we are running the TPCC against it, now we are seeing some select statements there. And okay, so there are many things to tweak here, and there's something like query plans. Let me check. But okay, now as we are seeing some outputs, that means the TPCC is really running. And okay, come back to the Grafana dashboard. So we are seeing the new TiKV node, and I think there's some balancing works between the TiKV, and we are seeing that the TiKV3 nodes is picking some leaders for the regions gradually. And now we want to try one thing is we want to scale in the cluster by one node. So different from the scale out operation, which happens instantly, right? For scale in cluster, let's say if we delete the TiKV3 node, if we blow the TiKV3 node directly, then some of the leader are not evicted, so it will be a problem. So there will be some disruptions in the workloads, and we will see some difference in the query per seconds, right? And what TiDB operator will do is it will not directly remove this TiKV3 nodes. Instead, it will try to evict all the leaders on that TiKV nodes. And after all the leaders are evicted, then it will try to remove that node. So this is this makes our life easier. Okay, so let's try to change the replicant number down to 3 in this dashboard. Okay. Okay, we can see that the change is applied, but on the bottom half of the screen, the TiKV nodes are not changed directly, right? Because at this point, it's trying to evict some TiKV leaders from this node. Yeah, so it will take some time to evict all of them, but after the number of leader on TiKV3 drops to 0, we are supposed to see the pods being removed, being terminated. And we are seeing that, okay, now it's being terminated. And I think at this point, the leaders are all evicted. But there's some latency on the dashboard but later on we are supposed to see a drop for the leaders on TiKV3. Yeah, let's go back to the TiDB dashboard. I think we can refresh all the statements. And we are seeing more and more select at this point. We can try the slow query and see. Okay, these are taking these analyze statements are taking long, but you can see that the select statement could also take seconds to finish, and yeah, and at this point, I think these informations could be useful for performance tuning later on. Yeah. Okay, now go back to the screen, and we are seeing that TiKV3 node is now down because we are not seeing its metrics here. Okay, that means the node is actually being removed. Okay. Get pods. Let's see how many pods are still running. Okay, now we can see that only 3 TiKV instances are kept here. I think that's the most part of my demo. And before I remove all the resource, any questions? I'll take some questions from here.
Yeah, there was one question, for example, from AJ. There was, if some nodes are down for a while, how do you handle split brain?
How do we handle split spring? Okay, I think from my understanding, maybe it's not correct, but TiKV is it's basically using Raft to do the consensus. So, and for example, for when you want to write some data to the database, I think there's only one TiKV instance taking the write request. But for example, depending on the keys you are writing, it could be a schedule to one of the TiKV nodes to take the write request, but there's only one TiKV node taking the request. And if that node is down, then I think there will be some re-election will happen. So a new leader will be elected, and the write will be shifted to that schedule to that TiKV node. I think that's the overall overall theory, I think. So yes, since there's only one instance taking the write, so I think it's there won't be split spring. Okay. Yeah.
Yeah. And if there's any other, like, there's no audience questions currently that we haven't answered so far, but now we have a few minutes still left if anyone has them. So please do write your questions there. And was there any, I think you had maybe Hanlon, like a resource that you wanted people to know in the future regarding KubeCon or something where people should be learning more about these things possibly?
Yeah. I've just also shared the GitHub gist link in the with our staffs. So later on, I think we can also share this GitHub gist that I used. Yeah.
Perfect. And we now shared the presentation, but yeah, perfect. Now the GitHub link went to all the attendees. Perfect.
Yeah.
Yeah. But yeah, if there's any questions from the audience, now is the time to ask them. But yeah, did you have something coming up in KubeCon? I think you mentioned before.
Oh,
You
yeah.
wanted to tell people.
Yeah, sure. So here's a little advertisement. So in KubeCon is at the corner. So in KubeCon, my colleagues will host some presentations. If you are interested in TiKV, please be sure to visit this booth. And also, if you are interested in chaos engineering, we are also hosting. Chaos Mesh is also a project initiated by PingCAP, and be sure to visit this booth there. I think that's the information I have so far. Yeah.
Perfect. Great next steps and resources that people can utilize going further then. And we had a question from audience. I presume this could scale up vertically without downtime? Question mark.
Yes. I think Like I mentioned before, I think in our environment we will set up something like a VPA to scale up the, for example, memory and CPU for nodes. Yeah, that can happen, but you need to configure a VPA on your own. Yeah.
Perfect.
Mhm.
And we do have still a few minutes, so if anyone has any questions and are typing them out right now, um, please send soon. But Hanlon, is there anything else you want to still share?
Yeah. Okay, I think the final thing is I will just show how to remove the cluster, how to clean up the resource. So basically, in the command line, let me just do a watch here. Yeah, you simply remove the cluster, and you can see that the pods are gone, and you also need to delete the TiDB monitor. Yeah, the monitor resource is now gone, and then you need to remove the PVCs and the persistent volume. Yeah, and I think that's it. That's basically what I want to cover in this presentation. Yeah.
Perfect.
Mhm.
And then I guess we have a comment from Massimo to the scaling vertically without downtime. They say, I think, scale out strategy, which,
Okay.
yeah.
Thanks for the comment. Okay.
Yeah. But yeah. So final call for any questions, if anyone is typing something out. But any final words from you, Hanlin? Anything to say, add to the end here now?
Thanks for joining the webinar. Yeah, I think that's all I have to say. Yeah.
Perfect. Thank you so much. And since no new questions have popped up, we can start wrapping
Mhm.
up. Thank you, everyone, for joining the latest episode of Cloud Native Live. It was great to have a session about how to build a multi cloud database as a service. Um, Really love the interaction and questions from the audience. So many of them. Always great to see that. And as always, we bring you the latest cloud native code every Wednesday. Um, for the next few weeks, we will have a break because KubeCon is happening. But after that, we have a lot of great sessions coming up. So stay tuned for those. But thank you for joining us today and see you next time.